Hello, Business Analysis Techniques. This is Unit 5. Welcome to Unit 5. This is your online instructor, Diana Block. And I want to take some time today to talk to you about the Unit 5 assignment. The Unit 5 assignment is located in the course content area. And let's see, where is it? Here you go. Here's your Unit 5 information. Unit 5 covers Chapter 7 in the textbook. So read through Chapter 7. Keep the PowerPoint with you as well. You don't want to go through the PowerPoint. I also highly suggest that you go through this video example that's in the additional learning resources. That's going to see you live watch someone. This will allow you to watch someone live walk through a full linear programming problem using Solver. So I'd encourage you to view that video before you get started on your problems that are for your homework. Of course, we have discussion this week as usual. So I'm going to spend most of my time though this week just looking at the Unit 5 assignment. So I'm going to open up the Unit 5 assignment spreadsheet. So again, you're going to be working on this after you have read the chapter and viewed the PowerPoints and viewed the example video. So if you haven't done all that, everything I'm doing might not be immediately clear to you now, but you're going to put together what I have in this video with what you're about to read and study in the PowerPoints. But I just want to give you some information so once you get there and you've done your reading, and you've viewed the PowerPoints and the video, make sure you know where to start when you get to your assignment. So this assignment, I'm looking at problem 1, and what we're trying to do is maximize profit. We know what our profit is per unit of products. This company apparently makes air conditioners and fans. And the paragraph up there tells us that the air conditioners are $25 profit each and the fans are $15 profit each. The paragraph also tells us about the time it takes for wiring and drilling each of these products. So based on the amount of time that it takes and the profit for each one, and considering that we have limits on the amount of time we can spend wiring and limits on the amount of time we can spend drilling in a given period, we want to find out what to produce to create maximum profit. How many air conditioners, how many fans, so that we have maximum profit within the time constraints that we have to work in. So the way that you are going to set this problem up is when you do the reading, you're going to learn about the objective function. So in this particular problem, the objective function, what we're trying to maximize is profit, right? We're trying to have the most profit that we can. So that's what our objective function is going to be. And the problem tells us that air conditioning profit is $25. It tells us also what fan profit is, so we would fill that in. Then the first thing I would suggest that you're going to do is write a formula for profit. So profit then is going to be the number of units of air conditioners that we produce times 25, because every air conditioner that we produce is $25 profit. And every unit of fans that we produce is going to have $15 profit. So this formula for profit is basically going to say the number of units of air conditioners times 25 plus the number of units for fans times 15. That's our total profit. That's the number we want to maximize. So we're going to put that formula for profit in this cell. Now, you see down here it says constraints. I'm wanting you to write in what the constraints are. We have two constraints. We have a constraint on wiring, and we have a constraint on drilling. Now, this problem tells us that each air conditioner requires 3 hours of wiring. So you could put 3 hours under air conditioning and wiring takes 3 hours. Then the problem tells us that each air conditioner requires 2 hours of drilling. So I can put here under air conditioners and drilling, that's 2 hours. So I'm getting my constraints filled in. So then here you're going to go through the paragraph, the problem, and find the same information for fans. How many hours of wiring do fans take? Put that here. How many hours of wiring does drilling take? Place that here. So then we can put in our total that we have available for wiring. We have 240 hours of wiring time. That's what the problem tells us. We also have 140 hours of drilling time. And I'm going to put these over here. What we have available. This is what we have available because I want to save this other column for something else. Okay. So I have already here the hours it takes to for the air conditioners, for both wiring and drilling for air conditioners. You're going to add in here the number of hours it takes for wiring and drilling of fans. Okay, so we'll have both of those numbers filled in. So then right here, I want to total all of the wiring hours because we've only got a total of 240 hours. So for every single air conditioner, there's going to be 3 hours of wiring. For every single fan, there's going to be a certain other number of wiring that you have to fill in. It's up in the paragraph. So the total wiring hours is going to be a formula that says the number of units of air conditioners times 3 hours plus the number of fans produced times however many hours of wiring each fan takes. That's going to give us our total wiring number. Then we're going to put a formula in here for drilling that says the total number of air conditioners times 2 hours plus the total number of fans times those required hours equals the total drilling hours. Now what we have to tell solver is that the total hours of wiring must be less than 240 because that's what we've got. The total hours of drilling has to be less than 140 because that's all we've got available for drilling. So I'm going to go ahead and finish this one up. Well, take you further on this. I won't totally finish it because you've got to fill in the top. So the problem tells us that wiring for fans is 2 hours. So that's already given. The problem tells us that drilling for fans is 1 hour. So however many units of air conditioners that we produce is going to require 3 hours of wiring. However many fans we produce is going to require 2 hours of wiring. Oops. Yeah, take it. Okay, so you can see what formula I have in here up top. And I'm going to put sum. Let's put sum just to make sure Excel takes this right. That's why I didn't like it. Yeah, I like that better. Okay, so you can see up here the formula that I have in. In this cell, I've got the sum of the number of units of air conditioners times 3 hours of wiring each plus the total number of fans produced times the number of wiring hours, 2 hours. So this is going to give me the total wiring hours. We're going to make a similar formula for drilling. Every air conditioner requires 2 hours of drilling. Every fan requires 1 hour of drilling. So we're going to take the units times the number of hours for each one and sum those, put the formula here. So then I've got this less than symbol, meaning this number needs to be less than 240. This number needs to be less than 140. Okay? And we've got a formula in here that I already discussed for profit. And to get profit, we're going to take the number of units times 25 for air conditioners, and the number of units of fans times the 15 for profit. So we'll have a formula in here. So then once we've got all the formulas in there of how everything ties together, all we'll need to know is how many units do we need to produce and what is that maximum profit. So I'm going to just walk you through and show you what solver looks like. So you're going to go to your solver, and in solver, again, you will have read this in your book and you will have seen this in your PowerPoints and viewed the video, but I'm just showing you now what you're going to see. So what we're going to do, solver says, what are you trying to do? What are you trying to do? What's your objective? Remember, the objective was this profit here. So the objective we're trying to set is the profit field. So we're going to put whatever cell that maximize profit formula is in. That's what's going to go in our set objective. What are we trying to do to profit? We're trying to maximize it. And so we've got max marked there. And so, okay, how are you wanting to maximize profit? We want to maximize profit by changing the number of units. Okay, we want to determine how many units to maximize our profit. So we've got that filled in. Then it says subject to the constraints. What are the constraints that we're working under? Well, we have two constraints that we're working under, and they are the amount of wiring time and the amount of drilling time. These are the two constraints we're working under. So we need a cell reference for our constraints. So let's say this cell here, D8 in my case, this is the cell that contains the total amount of hours for the number of units that are produced, the total number of hours for wiring. That number needs to be less than or equal to this number here, 240. Oops, go back. Okay, that's what goes in this cell, D8. So this cell needs to be less than or equal to the constraint amount, which is 240, and it happens to be in cell F8. So look at what this is really saying. This is saying that whatever's in D8, which is this cell here, needs to be less than or equal to whatever's in cell F8. So that's telling solver that the total wiring, because we've got a formula in there for wiring, that total formula needs to calculate up to less than or equal to 240. And so then we add that constraint. We've got another constraint that drilling also needs to be less than or equal to the constraint. So we'll add those. And then we're done. And it's not taking this one because I have an empty cell here. I didn't fill the formula in, but I just wanted you to see it. So look here now. We've got our solver window again, where we've added the two constraints. So on this first problem, you should have these two constraints here. So we were basically saying we're going to set the objective as profit. We want to maximize it by changing the number of units subject to these particular constraints. And we're going to make our solving method GRG nonlinear. We use that for problems that are nonlinear, so you're going to read about that. One of your other problems, problem 3, is going to be simplex LP, and so you'll read about that, but this one is GRG nonlinear. And when you've got everything in there, you'll click solve, which isn't going to work for me because I don't have everything filled in, but you'll click solve and it'll say we found you an answer, and then you'll have your results. You will have, when you get done with Solver, this information will be filled in. It'll tell you how many air conditioning units and how many fan units to produce, and it'll also have in there what that maximum profit is that you can make subject to those constraints. Okay, so you're going to do similar setup with each of these problems. So I'm looking real quickly at problem 2. And you've got an objective function that you're trying to maximize, which in this particular problem also happens to be profit. So you're going to put the profit per model in each of these. You're going to put a formula that calculates profit into this cell. You're going to list your constraints down here, which in this case you have one constraint, which is labor in this particular problem. Set that up the same way I did the other one. Now, problem 3 is a little more interesting. It looks like it's really long and different, but you're going to still do the same step by step. Your objective function, in this case, you're going to read and see what it is that you're trying to maximize. And in this particular one, it's going to be a formula that you're going to enter to maximize the profit. For each model, you're going to create a formula that takes the profit per unit times the number of units. Let me make sure this is the problem. I think it is. Yes. Yeah, you're going to take put a formula here in each one of these. Put a formula that takes the profit per unit. For XJ201, here's the profit per unit, times the number of that particular model you're going to produce. Then here, you're going to do the same thing. Put a formula that takes the profit per unit times the number of units. So then in this cell, for the overall profit, all you have to do is sum all of these. Okay, so calculate each one of these objective functions individually. So you're going to have dollar amounts in here. You're going to have dollar amounts because you're taking the profit per unit times the number of units. Now, the part that makes this problem interesting is the constraints. This is where people tend to get thrown off. So on your constraints, I'm going to tell you what they are, and you'll have to determine the formulas to calculate them and set up the constraint. But here's the constraints that you have in this problem. You have wiring, drilling. You're also given a constraint on assembly, inspection, and here's the one everybody misses, minimum required. You're going to have a constraint that tells you the minimum number of each model that you can produce. So you will have, in Solver, you will have a constraint for each one of those models that they minimum produced has to be at least that many. And so that information is given up in the problem. So I'm just kind of giving you a head start. I don't want to do it all for you, but I'm just giving you a head start on this. So that will get you started, and we're running on 18 minutes on this video, and I'm trying to keep them short. So between the reading, the example video, and the PowerPoints, then after you do all that, come back to this, and I think you'll be good to go. This is a very interesting chapter. Solver is a great tool. Once you know how to use it, you can solve all sorts of cool problems with it. So good luck on chapter 7. If you have any questions, feel free to email me. I will be online tonight for office hours, but you can email me at any time. So have a great week.